Hey there, fourth grade. This is Mr. Campbell. Today we are going to be working here in Topic 8, Lesson 1, Equivalent Fractions, Area Models. And at the end of this, we want you to be able to say, I can recognize and generate equivalent fractions. All right, so what that means is we want to be able to see and find equivalent fractions and then also create our own equivalent fractions. And so if you're sitting there going equivalent, that sounds like equal, right? That's exactly right. Equivalent is going to mean equal. All right, we've got that same beginning right at the beginning of our word equivalent, just like an equal, and that's a big clue for us. So let's take a look at what does this actually look like and how does this work as we turn to page 294. So here we are on page 294. All right, grab your pencil and follow along. Now remember, whenever I'm writing on my page, I want you to write with me. This first one, we're just going to be looking and following along, so nothing too much to write down, but I do need you to pay attention because this is going to be the really important meat of what we're going to talk about today. It says, James ate part of the pizza shown in the picture on the right. He said 5/6 of the pizza is left. Cardell said 10/12 of the pizza is left. Who is correct? All right, so here's our pizza over here. We've got our fraction down here. Now remember, a fraction is going to be two parts. The numerator is what's on top. Denominator is down below in the bottom part. And they're separated right here by our line right here. So this is a fraction right here. All right, what that means is that we do not have a whole number. If we look at our pizza up here, the whole pizza, it would be this whole tray, right? We don't have a whole pizza because there is some that is missing, which means that what's left is a fraction, all right? So if we look back over here, James says there is 5/6 of the pizza left. Cardell says 10/12 of the pizza is left. So what we're looking for today is equivalent fractions, which will name the same part of the same whole. So when we look at our pizza here, we're going to say, well, is it possible that this could be 5/6 and 10/12? Well, let's come down here to box B and take a look. It says, use an area model, draw a rectangle, and divide it into 6. Well, that's what we saw up there, right? We've got 1, 2, 3, 4, 5, 6. So we draw our line across and then 2 up and down to create 6 spaces. Then we shaded in the pieces that are left. So that's the blue that's left. All right. 6 pieces will make our whole. That's why our denominator is 6. And we have 1, 2, 3, 4, 5, which is why that's our numerator. All right. So it says to shade our 5/6. All right. There we go. Now it says, what if we wanted to make that into 12ths? Well, the red line here shows us we took the same thing and we drew a red line here, and look how many there are now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how many of those 12 are now shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number and size of the parts may differ, but the shaded part of each rectangle is the same. 5/6 and 10/12 are equivalent fractions. All right. Did the shape of our pan change when we added more slices, when we made it into 12 slices? No, the whole did not change. The pan didn't change. Did the size of our pieces change? Yeah, they certainly did, right? When we take a look here, this piece is much smaller than here. But there's the same number of open space on both of them, all right? And that's how we can see equivalent fractions. Here's another way to look at it. We can use a different area model by drawing a circle and dividing it into 6. All right. So we went straight down and then we made our crosses. So, hey, there we go. We shade in 5/6. 1, 2, 3, 4, 5. 5/6. Then we can divide that, keeping the same thing. We can cut all of those pieces in half to make our 12ths. The number and size of the parts differ, but the shaded part stays the same. The open space is the same, and the amount that was shaded on both of these stayed the same. So, at the end of all of this, we could say, well, both James and Cardell are correct because 5/6 is equal to 10/12. And that's how we write equivalent fractions. We put one fraction on one side, our equal sign, and then the other fraction on the other. All right? And that's one way that we can see, oh yeah, these are equivalent fractions. All right, well, grab that pencil. Let's go to page 295 and do some work together. So here we are on page 295, and we're going to start with number 1. And it says, use the area model to explain why 3/4 and 9/12 are equivalent. All right, we're going to ignore these dotted lines for just a minute and just look at our solid lines. All right, so our whole is going to be this big rectangle all the way around here. All right, and when we see that, we can see that we drew our lines to go up and down to make 1, 2, 3, 4. Right, so that's where our 4 in our denominator comes from. Go ahead and write that with me. Now I'm going to ask you, of those big up and down ones, how many were shaded? How many were shaded? Well, we had 1, 2, 3 shaded, right? So we have 3 shaded parts, and so that's going to be our numerator. All right? So our numerator is 3. Our denominator is 4 because that's how many we would need to make a whole. All right? Now, let's go ahead and we're going to go ahead and go over it with just like that. Perfect. So there are dotted lines. We're going to turn them into solid. All right? Now that I've done that, let's see how many does it take to make a whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be my denominator. Okay. How many are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9. So did I change how much it was going to take to make a whole? No. Did I create smaller pieces? Yeah, I sure did, right? But overall, these are still the same because the same amount of white space is still there. It's broken into some smaller pieces here, but it's still the same. The colors that the shaded part in is broken into smaller pieces, but it's still the same amount of space that is done, all right? So that's how we can know that. Well, let's take a look at number 2. It says, find the missing numerator. Remember, numerators are what are on top. Our first one, we have 2/4. So that means when we look at our square here, all right, the one that's broken into fourths is what we started with. So 1, 2, 3, 4. And how many were shaded? We had 1, 2. Okay. Well, the next thing they want us to do is they want us to say, all right, well, if we broke that into eighths, so I'm going to go ahead and connect my dotted lines here. All right. Now I've got 1, 2, 3, 4, 5, 6, 7, 8. How many of those are shaded? Well, I've got 1, 2, 3, 4. Which means 2/4 is equivalent to 4/8. The whole didn't change. We just made the pieces a little bit smaller. Take a look at number 3. Find the missing numerator. We had 1/3. So again, our solid lines. The whole is the big rectangle. We've got 1, 2, and 3. All right. And only one of them was shaded in. Well, when we choose to break those into smaller pieces and cut each of those in half, what do we have now? Well, 1, 2, 3, 4, 5, 6. And then how many are shaded? Well, there's only 2 shaded, so 2/6. All right. Well, let's go ahead and come on down here. I want us to check out, we're going to do just one more here in our independent practice. We're going to start with number 5. All right. So we're going to start with number 5. It says, write 2 fractions that are equivalent to 4/12. All right. So equivalent to 4/12. Well, this gets a little bit trickier here, doesn't it? Yeah, it gets a little tricky because I can see, well, I have a lot of things kind of drawn on here, right? So let's go ahead and try this out. So I'm going to take my pen and I'm going to go through like this. And there's 1, 2, 3, 4. 1, 2, 3, 4. So if I extend that out, and then 1, 2, 3, 4. Hey, the lines that I just drew like that, you see how I drew on there? Well, I now made 1, 2, 3. If I take a circle, I'm going to draw one real quick, and where these lines that I just drew, I've made thirds, right? It's the same. I made thirds, and then I can just shade in the part that was shaded over here. Well, what's this fraction that I just made? Well, how many does it take to make the whole? 1, 2, 3, right? So my denominator will be 3, and how many did I shade? I just shaded 1. So 1/3 is equal to 4/12. Huh, okay, that makes sense, right? All right, well, let's go ahead and do another one. So I'm going to draw another one like that. Well, I'm always about keeping it kind of easy on myself. And so when I've got my thirds, all right, if I cut each of those in half, what do I have now? 1, 2, 3, 4, 5, 6 is my denominator. And if I shade in the same as on that first one, how many did I shade in? 2/6 is equal to 4/12. Okay. Circles can feel a little bit tricky. When we see them, we can see it visually, usually a little bit easier, but it can be a little bit tricky for us to kind of see what that looks like. All right. So when you're working on these other ones, you can see here it says write an equivalent fraction for 1/5. All right. Well, when you do that, they've drawn the dotted line on you, so you can go ahead and then count that up. All right. Write an equivalent fraction to 2/6. All right. You can do the same thing I did here by extending those lines and then figuring out what you got. All right. And then same with down here. Write two fractions equivalent to 2/3. Well, here's your 2/3. All right. We can always cut those into smaller pieces, and that's one way for us to do it. We just need to make sure all the pieces are cut equally. We don't just do some and not others. All right. Well, let's go ahead and go down here to number 8 through 15. All right. 8 through 15. Now, these can feel a little bit tricky, and so that's why I want you to check it out real quick. All right. I'm going to go ahead and draw a quick rectangle, and I'm going to make it into 8s. Well, the way that I'm going to do that is I'm going to cut it into 1, 2, 3, 4 equal parts. And then if I divide that in half, there. All right. So here is 2/8. All right, 2/8. Now underneath it, I'm going to draw the exact same rectangle, but this time I want to cut it into 4 equal parts. And so I'm going to try to make sure that those are all equal parts, just like before. And if I shade in the same amount that I had up here, how much did I shade in? I only shaded in 1 of my 4 parts. So 2/8 is equal to 1/4. All right. Try number 9 real quick. I'm going to ask you, go ahead and draw this first rectangle with me. So 4 is my denominator. So I'm going to break this into 4 equal parts. And then 2 tells me I want to shade 2 of those in. So 1, 2. And then I want you to pause your video right now and see if you can do this second part. How many 8ths would that be? Well, draw your rectangle, divide it into 8 equal parts, and then see how many, if you shade it in just like you did up here, how many that is. So go ahead and do that right now. Pause your video and try finishing this problem. If you haven't paused, do that now. I'm going to go ahead and draw our rectangle. All right. So when I make my 8ths, all right, I see I need to shade in 2/8, just like before. But then I'm going to cut the whole thing in half to make 1, 2, 3, 4, 5, 6, 7, 8. All right. And how many are shaded? 1, 2, 3, 4 for 4/8. All right. I hope this is starting to click for you. I know it's kind of a tricky concept, but what we're really looking for is making sure that our whole stays the same. When we shade in our different parts, it should be the same amount of space that's been shaded in, but we can always break those into smaller pieces as we find our equivalent fractions. So I hope you guys have a great rest of the day. Thanks for working with me today, and we'll see you next time.